Okay, this video is going to cover section 3.4, the conditional and related statements. So pretty much it's mostly going to be about these three things right here, okay? The conditional statement is this one right here, P implies Q. So just so we know that this part right here, the conditional, is what we've been looking at for a while now. P implies Q, okay? And the related statement is going to be the part after that. So we have a couple of, or not even a couple, several definitions here that have to do with these different forms. Okay, we have the converse. The converse is pretty much, sorry about that. The converse is pretty much taking the P and the Q and switching them. So you see how here we have if Q implies P. Okay, so you just kind of swap these two. The inverse, okay, is negating both of them. So instead of if P then Q, we have if not P then not Q. Okay. And finally, last but not least, we have something that's called the contrapositive. The contrapositive is probably the one that people tend to forget. It's pretty much flipping them and negating them. So it's like a combination of the converse and the inverse. It's not Q implies not P. Okay, so we're going to just try practicing this using an example. I'm going to go ahead and scroll down a little bit. We have this example. It says, if we have a quiz today, then we will not have a quiz tomorrow. So I'm going to start by underlining what's P and what's Q. So this right here is our P, our antecedent, I still can't say that word. And we will not have a quiz tomorrow would be the Q. Okay, so we're going to start with the converse. The converse, I did that in yellow, is swapping them. So Q implies P. Okay, so what I would do with this one is I would swap these two. So if we do not have a quiz tomorrow, so I'm starting with the Q, okay, okay, then P. So we will have a quiz today. Okay, and that's pretty much it. I'm just switching the Q and the P. Okay, let's move on to the inverse. So now we have inverse is the next one. The inverse is not P implies not Q. So I'm going to just rewrite that right here. So we negate both of them. Not P implies not Q. So I would say if we do not have a quiz today, because we're negating this part. So if we do not have a quiz today, okay, then not Q. So not Q would be we will have a quiz tomorrow. So then we will have a quiz tomorrow. Okay. And the last one, last but not least, is our contrapositive. So contrapositive, again, is going to be this one right here. Not Q implies not P. So not Q implies not P. And that would be not this one. So if we do not have, let's see, well, actually, if we do have a quiz, because it's saying we will not. So if we do have a quiz tomorrow, okay, then we're negating P. So we will not have a quiz today. And that's it. That's pretty much these three devices in action, okay? So we're going to go ahead and scroll down a bit more and see how this can be used in another example. So, and this is actually real similar to one of your problems. It says, this is an example, okay? What is the inverse of the converse of the contrapositive of P implies Q? So I'm going to color code everything real quick. Make sure I did that in the right order. Oh, I did it backwards. Sorry about that. So the converse is in yellow, this one's in red, and contrapositive is in blue. All right, so for something like this, we're going to start backwards. So first of all, P implies Q. This is our conditional statement. This is saying if this, then that. Okay, we don't even know what they mean, what they represent right now, but we're just trying to show what this is going to come out to. Okay, so if I go backwards, the contrapositive would be next. So contrapositive. So the contrapositive of this is not Q, then not P. Okay, and then we would have the converse because that's going backwards. So the converse is when you take these two things and you swap them, okay? So in case you're not sure what I'm talking about, it's right here. The converse is just taking these two things and swapping them. So I'm going to do that next. So this would be not P. This one will go first. Implies not Q. Okay. And finally, we have the inverse. So I'm just kind of going in order this way. Okay. So the inverse for this one would be negating whatever is here. So negating these two things. But if you notice, if you negate a negation, well, you're just left with P and you're just left with Q. An interesting find. Okay, so it comes out to the same thing. With that in mind, we have one more example, I believe. This is, like I said, this is a kind of a short video. So we have this table, and it's in your book as well, that shows that any conditional statement, remember your conditional is just that P implies Q, okay, that's this thing right here, okay, is equivalent, meaning is the truth values are the same, to its contrapositive, okay, and the converse of the conditional statement is equivalent to the inverse of the conditional statement. So we're not going to do the whole truth table. We're just going to look at it and analyze this. Here's our conditional that I was talking about. And this is saying that if you were to work all this out, this comes out to the same as your contrapositive. So if these two things are the same, if the truth values are the same, okay, it's because they're equivalent. And actually, this will be equivalent every time if, you know, it's true, okay? Same thing with the converse and the inverse. So the converse and the inverse match each other up as well. And that's what these arrows are showing here. So these two will match up here, okay? So what we're going to do is we're going to use this information to determine whether these statements are equivalents, okay? And we're going to do that by first identifying P and Q. So letter A says if a number ends with a 5, so here we have our P, okay? Then the number is divisible by 5. So the number is divisible by 5 would be our Q. Okay, so this would be your P implies Q. This is the conditional. Okay, the second statement says, here, let me write that here. This is the conditional. The second statement says if a number is divisible by P, so you have your P again, then the number, oh, I'm sorry, not P. If the number is divisible by 5, okay, so notice that this is the same as this. So this is actually your Q, okay? Then the number ends with a 5. So this is your P. So in this one, we swapped them. They went ahead and did Q implies P because Q comes first. And this is, let's see, according to our chart up here, Q implies P would be the converse, not the shoes, just, the converse. So according to our chart, do these two match up? They do not. So that means that these statements are not equivalent. So this part right here for letter A would be not equivalent. See how that works? So if you're given a few statements and you can identify what they are, if they match up according to this chart, so the conditional and the contrapositive are are both there, then they would be equivalent. Same with the converse and the inverse. So these are not, so they're not equivalent. We're going to look at the second example. This one says if two lines in a plane do not intersect. So here we have our P. Two lines in a plane do not intersect. Okay, then the lines are parallel. Lines are parallel. So we're looking at our first line to be our conditional, okay, if that helps a little bit. So this would be our P implies Q, okay, the conditional. And the second part says if two lines in a plane are not parallel, so that kind of looks like the Q part here, except it says not, so that would be not Q. Then the lines intersect. So the lines intersect looks like it's part of the P, but it's saying they do, and this one says do not, so this would be not P. So it looks like this one is not Q implies not P, which if I remember correctly, you can check if you want, is the contrapositive. So if we have both of these, okay, are they equivalent? Well, let's see. Conditional, contrapositive, conditional, contrapositive. So yes, these statements would be equivalent. And I believe that is it. This is a really short unit. Um, so if you have any questions, like as always, go ahead and let me know.